Good evening, students. Welcome to day 3 of your 400 expected questions for your upcoming board examinations, grade 12 students. So once again, hello. Thank you so much for watching the earlier 2 videos. Second video is a little bit going slow. Please watch the video, students. I'm finding time to do it for you only. Please, again, my request, try to share it. More and more you share, more and more knowledge goes. So today, what is the speciality? Today we are going to do 2 questions, 5. Total 10 questions we are going to do, students. All are very important and expected questions. So I'm going to go with question number, basically 1, 2, 3, 4 I've got. So question number 5 questions. Question number 6, 5 questions. So total 10 will go in that. These 5 would be from your P block elements, right? It will be from D block also. Let me check. Then the next 6 question will be from your aldehydes chapter, alcohols chapter and ketones chapter. So stay connected, watch the video. My request is share it, watch it and get that knowledge. So take out your book, students, take out your pen, keep it ready, write it. Day 3, 400 expected questions. Let us read the question. Yes. So question says fluorine exhibits -1 oxidation state. Okay. Whereas other halogens exhibit positive oxidation states as +1, +3, +5, +7. Why? Simple question. Don't get confused. So as soon as this question is given to you, write like this. Whatever they have given, note it first. What did they say? Fluorine exhibits which oxidation state? Only -1. Other halogens like chlorine, bromine, iodine are going to exhibit, right? +1, +3, +5, +7 along with -1. This also is there. Why they are asking? Simple reason. Students, write the reason like this. What is this, students? Basically fluorine atom. You very well know in the periodic table among all the elements the highest electronegativity is fluorine. Correct, no? Yes. So fluorine, first important thing, why it is not forming so many? Point number 1, fluorine has highest electronegativity. What does it do? Whatever comes towards it, it tries to grab the electrons towards it. 4 is the electronegativity, isn't it? Right. Highest electronegativity. Okay. What is it related to? Electronegativity is related to what, students? Because of small size. Small size. Okay. Then what else do we require? When something has to give or donate electrons, it should require basically a larger size, more number of orbitals. Correct, no? Now check here. Absence of d orbitals. Absence of d orbitals. There are no d orbitals. When you see chlorine, bromine and iodine, they have d orbitals. Fluorine atomic number is only 9, isn't it? It doesn't have 1s2, 2s2, 2p6. If you see, no d orbital. So absence of d orbitals. Hence fluorine shows only -1 oxidation state. That's all. 1, 2, 3, 4 important points. Easy, isn't it? So when the question is given, try to write like this. And if you still want to be more specific with the examiner, write here also. You can put the other way, put one line like this, right? If you want to still write, if you want to impress the examiner, you can write about chlorine, bromine, iodine also. What you will write? Larger in size for this. Less electronegativity. Presence of d orbitals, hence they are showing so many oxidation state. Write the reverse of that if they ask. But they asked about fluorine, no? That's why I wrote about fluorine. If it is others, write the remaining thing opposite. Now let us come and see the next question. That is question number 2 of your grade, question number 2 of your question 5. Yes. Now let us come to the next question and solve the question. Right. So basically, students, in this particular video, I'm going to solve the question. I'm going to give you the notes how to write in the exam also. So directly note it and you can write it in the exam, students. Yes. So next question is, in question number 5, H2S is less acidic than H2TE. Quite common and important question, students. Remember. So H2S is less acidic than H2TE. Write like this the answer and note. So what did they say? H2S is less acidic than H2TE. If you write like this and leave, it will not be possible. So in terms of what you should say? In terms of acidic character. Which acidic character, students? Which acidic character? Increasing acidic character. Increasing acidic character. So what did they say? This is less acidic, this is more acidic. Why? So I said whenever acidic character questions are given to you, remember one important keyword. Simple. It has to release this H plus ion. Correct? When I see this sulfur to tellurium, which group is it? Group 16. So what are the elements? Oxygen, sulfur, selenium, tellurium, polonium. Correct? Now what did we do? We have taken the hydrides of this. So where did I take? I took this and I made H2S. I took this, I made H2TE. Now I have to release this. Now you tell me from top to bottom in the group, what happens to the atomic size? It increases. Write down the first point. What point? From top to bottom in a group, yes students, what increases? Atomic radii increases. Atomic size increases. When atomic size increases, you tell me which is larger in size? Tellurium is larger in size. Accepted. When the atomic size increases, the bond between, what is a bond? Between H2 and Te. Let me write like this. Bond between E and H. What is this E? E is the element. E is element. In this case sulfur, in this case tellurium. So you can write E can be sulfur or it can be tellurium in this case. Okay. E is sulfur. So the bond between E and H, what will it be? Size is larger. I can easily break the bond, isn't it? So which case I can break the bond? E and H bond, or the bond between E and H is weak between yes students, hydrogen and tellurium compared to which one? Hydrogen and sulfur. Now tell me if the bond is weak, because the size, see, hydrogen atom is smaller size, tellurium is a larger size. The bond automatically between these two is weak, isn't it? So what is going to happen? Bond dissociation energy. This word you need to write, students. Bond dissociation energy. So bond dissociation energy, that is BDE, is less. BDE is less for which one? Is less for your H2TE over. I got conclusion. I wrote top to bottom, size increases. Then I said the bond between E and H, that is sulfur and selenium, is weak, I said. Then what did I say? Bond dissociation energy is less for H2TE, I said. Now tell me, if the bond dissociation energy is less, I can easily break the bond and give that H plus. When something donates H plus is nothing but acidic in nature. So remember, bond dissociation energy is less, this one for H2TE. So hence, it can release proton H plus and is more acidic compared to H2S. That's all. Simple. I wrote whatever is there. I have written like this in words. Take your pencil, underline. Atomic size, yes. Bond between EH, weak. Yes. Bond dissociation energy, less. Hence, H2N, it can release proton and is more acidic than H2S. That's all. Simple question. Yes, students. So I'll lift just little camera, I'll adjust. So next question, let us meet with the third question. Right. Now let us solve the third question and the fourth question. Right. Now almost similar questions, so I picked up. Nitrogen does not form NCl5 but Phosphorus forms PCl5. Why? Simple, students. Whenever they talk about a compound with a higher oxidation state, think about whether it has d orbital or not. First concept. Now when I take this, nitrogen does not have no d orbital. Point number 1. Okay. Then next important thing, in nitrogen, if I have to tell you, the size of the atom is smaller. Okay, nitrogen is smaller atom. Okay, now next one. What is important? Next important thing, when there is no d orbital, smaller size, can it accommodate chlorine? Correct. So cannot accommodate chlorine atom. So hence what should you write? Hence NCl5 does not exist. Suppose if you want to write the reverse, so same like this, keep phosphorus here, write down because of the presence of d orbitals, group 15, it is like atomic number 15, no? Yes, so larger sized atom can accommodate chlorine, it can show more oxidation state, hence PCl5 exists. Like that you need to write for both, your wish. If you write for this also, you can get marks. Right. Next question, students. SF6 is well known, but SCl6 is not known. Almost similar questions. See here. When I take sulfur atom, okay, 1, 2, right? Now, let me write like this. Not like this, little bit down I'll write. So, 1, 2, 3, 4, 5, 6. So, fluorine. This exists, it seems. That is, SCl6 is not known. How does that 6 look like? Sulfur down. So, chlorine atom 1, 2, okay, 3, 4, 5, 6. Now, let us fill the electrons. So, chlorine, this sulfur 1, 2, okay, 3, 4, 5, 6, 7 and 8. Like that, for every chlorine atom there are electrons. Every chlorine atom there are electrons. So what is going to happen? There are lot of electrons which is causing which one? Steric factor. Lot of electrons and steric hindrance. It is creating that strain in the molecule. So let us write. In this case, what happens, students? Write down. Fluorine atom is smaller. Okay. Fluorine atom is smaller. Okay. No steric, means no bulky groups rather. No steric hindrance. Correct. Hence SF6 is stable. SF6 is stable. Now if I have to write SCl6, what happens, students? Chlorine atom, okay, write full form please, don't write shortcuts like me. Chlorine atom is larger in size, more steric hindrance, hence less stable, Simple. Correct. That's why SF6 is known, well known. SCl6 is not known because the molecule is not stable. It is unstable. Because of this, it is. So if I have to write hence unstable, let us write this. This is more appropriate. Got it, students? Now, so answers I have written both. Now let us come and see the next question. Right, students. So now let us come and see the last question of your fifth part. So what did they give me? HCl when reacts with finely divided iron forms ferrous chloride, not ferric chloride. Why? Now we've already studied metal plus acid gives me salt plus hydrogen gas. Remember? But here what are we going to take? We are going to take iron. We are combining with HCl. What did we say? They have it's giving ferrous chloride. What is ferrous chloride, students? FeCl2. Along with this, hydrogen gas also is released out. Now check, hydrogen is 2, so I am making 2. Chlorine is 2 iron. Now this part is called ferrous chloride. So normally what happened here, hydrogen gas is already released in the reaction. Correct? No. That hydrogen gas, because of that release, it will not convert further ferrous to ferric. So once again reason, because of the release of hydrogen gas, because of the release of hydrogen gas, what happened now? Because of this release of hydrogen gas, what happens? It prevents ferrous chloride, that is FeCl2, to get converted to ferric chloride, to get converted to ferric chloride. That's all. Easy, isn't it, students? So FeCl3. Simple. Now let us see one aldehydes ketones reasoning question. Right, now let us come and see the sixth question, part A. Aliphatic aldehydes do not show position isomers. Why? It's a very easy question, students. So basically, aliphatic aldehydes position isomers. So remember, students, whenever we have to write position isomers, simple. What we do? Suppose there is one alkyl group like this. Okay. Now what am I going to do? There is one substituent or something. Or if you have a group, or here in this first carbon, after some time, what do? I'm going to shift this to this particular position and show them, okay, one methyl is there it is 3 methyl, like that position change I'll show. But in this case, what happened? Aliphatic aldehydes, when I take, what happened here? The aldehyde group is at the terminal position. So let us write that. What is this? Aldehydes, aldehydic functional group is present in terminal position, okay. Then no, when it is in terminal position, when you're counting, what do? You count as 1 and 2. Can I take that and place it somewhere else? I can't do, no. Here means it is substituent. I took from here, placed it here. After here, I can place it here. But in this case, what happened? Aldehydic functional group is present in the terminal position and cannot be shifted. Hence, it will not show any position isomerism. So the key word is aldehydic function group at the terminal position, at the end. It is at the end. That is called the keyword. So I can't show any position isomerism. Let us see this question. Why do aldehydes and ketones have high dipole moment? Simple question, student. See here, aldehydes, when I take, suppose, check this. Carbonyl carbon along with this oxygen. This can be anything. It can be a hydrogen or alkyl group. What is happening here? First point, your oxygen is more electronegative. Point number 1 is oxygen is more electronegative. Okay. If it is more electronegative, what is that thing? It's going to pull the electron density towards itself, and this will get partial negative charge and this will become partial positive charge. Yes or no? Now you only tell me, are there no two poles created? Correct. So what is happening now? What is the reason? Aldehydes and ketones have dipole moment because oxygen is more electronegative. Hence it pulls the electron density and forms poles and forms 2 poles, or it forms dipoles. Okay, 2 poles are formed, positive and negative. Suppose if I take the same part, check. I have formaldehyde here, formaldehyde. You know what is the dipole moment? The electrons move towards this. The dipole moment is 2.29. If I take acetaldehyde, CH3CHO, here the dipole moment is almost 2.5. If I take a ketone, CH3C double bond O, CH3, here the dipole moment is almost 2.9. Why? Because of this oxygen atom. So right here, simple question, 1, 2 are over. Now let's come and see 2 more questions. Yes, the next question, I think you're all noting it. Yes, students. What do you expect benzaldehyde to be more or less reactive in nucleophilic addition reaction than propanol? Two things are given. One is benzaldehyde. One is propanol. Both are aldehydes. One is aliphatic aldehyde, one is aromatic. Then more or less reactive in nucleophilic addition reactions. Simple, students, nothing. They said, how are you going to justify whether benzaldehyde is less reactive or more reactive? So as soon as this question is given to you, write like this. Now propanol, CH3CH, okay, let me write like this, CH3CH2C, okay, your double bond oxygen is here, let me write oxygen and hydrogen. Propanol, 1, 2, 3. Benzaldehyde, your benzene ring, in this case C double bond O and H. Check. Here what is happening, students? What groups are there? Plus I groups. Here in this case what happens? This aldehyde is going to pull the electron density towards itself. So oxygen is electronegative. So from here this bond shifts. Yes or no? So now check what is this type of effect? This is called minus R effect. Now you only tell me, is there any resonance here? No resonance. Is there any resonance here? Yes, it is resonant. So resonating structures, what happens, students? They are more stable. Correct? Now in this case, minus I effect keeps on donating electrons. Yes or no? It keeps on donating electrons to this. So what is going to happen? This is becoming less stable, more reactive. Correct? No? Less stable, more reactive. More stable, less reactive. So why more stable? Because of resonance. That's all. So now you can prove, no? What do you expect benzaldehyde? Yes, benzaldehyde is less reactive than propanol. Why? Because minus R effect, point number 1. Second, it shows resonance, point number 2. It is more stable, point number 3. If something is stable, it is less reactive, isn't it? That's all. So you can write here, benzaldehyde is less reactive than propanol. That's simple. Reason is here. Let me draw one line not to confuse you. Now this is an easy question. Boiling point of aldehydes and ketones is higher than hydrocarbons of comparable molar mass. So boiling point. So whenever boiling point question is given, now write down, students, in aldehydes, HCH3O, oxygen atom, there are two poles, whether or it is in ketones, HCH3, C double bond O CH3. Here also two poles. This is positive charge, this is negative charge. Here positive charge, this is negative charge. Now you tell me, in this case, what forces are existing? What forces? In case of aldehydes and ketones, you have dipole forces, correct? No? Dipole interactions. Okay, dipole interactions. But in case of hydrocarbons, CH3, CH2, your CH2, long hydrocarbons, what forces? Weak London dispersion forces. Weak London dispersion forces over. So you can write directly when we see the forces, weak London dispersion forces. So in A and B, what will you write? A forces are stronger than forces B. Means dipole forces are stronger than your London dispersion forces. Hence, what will you write? Hence, your hydrocarbons will have more boiling point than aldehydes and aldehydes and ketones have more boiling point than hydrocarbons. So you can write the examiner and tell them, sir, because dipole interactions are stronger than dispersion forces, I require more boiling point. That's why Aldehydes and ketones have more boiling point compared to hydrocarbons of comparable molar masses. What is the keyword? This is the keyword. This is the keyword. Got it, students? Chalo, last question for today. Yes, students, now the last question. Let us read this. So, what is the order of the following in increasing order of nucleophilic addition reactions? So, they have given me what? They have given me 2 aldehydes. They have given me 2 ketones. Remember. Now, as soon as this is given, what are they saying? Basically, among all these aldehydes and ketones, which is more reactive towards nucleophilic addition reactions? Point number 1. Ethanol and propanol, let us check. So, let me make one table. So, aldehydes are on one side, ketones are on one side. Okay. Now, generally, if I write, in aldehydes, you have hydrogen, carbon, oxygen and one methyl group. When I write ketones, you have CH3, double bond O, CH3. Now, what is happening, students, here? Here, there is something called plus I effect and there is a lot amount of steric factor. Means plus I effect is trying to give electrons and it's giving electrons and electrons to this carbon. Oxygen is trying to pull this electron towards it. So, what is happening? Already, it has excess electrons present on it. Now, will it accept or allow or attract that nucleophile? Nucleophile also is electron rich. So, what is going to happen, students? Steric factor and plus I effect. What is happening? Steric factor, point number 1. Plus I groups are more. Point number 2. Hence what happens? Does not prefer nucleophilic addition reactions. So, one more factor also is there, electronic factor. So, nothing to confuse you all. You can write this. This is enough. Now, in this case, what happens, students? Only one alkyl group. Okay. Less steric factor. Then, easily attracts, because hydrogen atom is smaller, no? Hydrogen easily attracts nucleophile for addition. And one more case here is hydrogen atom is smaller. That's all. Simple. So here you can write electronic factor also works if you want to write electronic factor. Due to electronic factor. That's easy, students. I did 10 questions today so that you will note it, and tomorrow I'll come back with one more. There may be physical chemistry also. Anything can come tomorrow. So please watch, share it, and I want more and more students to know. So please make it a success before evening, tomorrow evening. When you see this, all your questions, how many till now we did? 10 and 12 and 14. 14 questions, you should become perfect. Thank you so much, students. Bye-bye.